Okay, very good morning, everyone. Meet you again. This is week 3. Oh. So have a seat, please. Make it faster. We are left only, I think, 50 minutes. So I wish that I can complete this topic. Yep, yesterday I did. So I hope that I can make it for this session. So this is the topic for this week, week 3. We have done with week 2, the digital numbering system. So today we go for the operation. As usual, for the operation, we'll be given by certain of operations. We need to know how to do the operations of the addition, plus, and then second, subtraction. Next is multiplication, and the last but not least is division. And we have two types of the numbering. First is an integer, another one is a floating point or real number, decimal point number. Okay, so let me start. All right, this is the one. The learning outcome for today, I want to make sure that you understand how to do the operation. And then next week, week 4, we do exercise on this, okay? Some of slides I need to skip, so to ensure that we can cover today for all the operations. So let's go. Without further delay, let me see. Okay, as you can see in the slide, read 1 minute. Okay, we have two types of a number. So introduce to you, for those are not done yet with the tutorial, I guess that this is new for you. For those are done with the tutorial, you know, we have two types of a number. One is unsigned, and another one is a signed number. Unsigned is representing positive number. And signed, okay, when you have a question that asking about signed number is referring to the number negative number. So I put that 1. So negative number, normally in the binary, we used to have a number 1 to the front of the number. Okay, for example, we have a 11001. So you will see in the front of a number, and the first digit character is a 1, because I said 1101. If let's say you have a number 00011011, so you see the frontal number, the first number in the digit positioning is a 0. So that is positive. So we can have like any of a number, decimal, we understand that is our numbering system. We have a 1, 2, 3, 4, 20, 40, 50, 60, 100. That is our numbering system, our system number that we are very familiar with. So that numbering, basically when you convert to the binary, it is a positive. We also have a numbering system negative, like negative 34, we have negative 50, negative 100, all the number negative representing in the binary, which is 1. So this is what I mentioned. Those are doing the quiz. We have a sign, one of a question, sign number for negative 3. So we know in the binary, negative 3 is a 1, 1. Sorry. We know in the binary number, 3 is 1, 1. So if we want to convert that to become 1, for the 4 bits, we have a 1, 0, 1, 1. That one for the sign. Okay, for the 1, for the sign, negative. So I am representing negative 3 to become 1, 0, 1, 1, if I have a 4 bits. And next, if let's say I want to presenting 3. In the binary, we will convert 3, decimal number, to binary, we will have a 1, 1. So we have, if I want to ensure that this is a positive, for the 4 bits, we have a 0, 0, 1, 1. So remember, what is an unsigned? Unsigned for the positive number. Negative number is a sign. So sign representing with 1 to the front of the digits, and this is 0. Correct? Okay. Continue. Huh? If I talk too fast, I can't talk too slow and slow because we only have a 1 hour. So let's go for an example in this case. Take a look, 1 minute. Okay, let's go for the example number 1. Okay, that question is said store 7 in 8 bits memory location. So what you're going to do, in the first place, that you see 7. This is not binary, so we need to change the 7 to binary. And if we convert this decimal 7 to binary, this is the number 111. Okay? So first, what you need to do, you need to change this decimal number to binary number. Just example, okay? And then second, if let's say there's 8 bits, so you need to have a 8 positioning. 8 digits, 8 bits. So 7 in binary is a 111. Look at to number 2. Look at to number 2. 1111. So you need to add another positioning to ensure that become 8 bits or 8 digits or 8 character. So that is example number 1. So this is the way how if you input 7 using the calculator, so this is the number has been decoded by our computer processor. Okay, and they're going to be loaded to the memory. So same goes to example 2. We have a 258. So 258 is a positive, is unsigned character, 7 also unsigned character, but this time around, it says store this to 16 bits. So 16 bits, we understand that we have 16 location in this case. All right, next. Okay, I have who are done tutorial with me. I did discuss about first complement. Okay, the other lecturers, co-lecturers, some of them they did. All right, never mind. We go through. Okay, we cross-check about the first complement. We have a few of a bases. First of all, we have a first complement. Next, we have a second complement or 2 base. Binary, we have octal, which is 8 base. And then we have, what else? Decimal. We have a decimal, 10 base. And last but not least is a hexadecimal, 16 base. So that is the numbering system that we understand, okay, for computer architectures. And the most important numbering I mentioned in my tutorial, when you do the conversion, okay, as long as you know how to convert binary to decimal or decimal to binary, that's good enough. It is good enough. Why? From the binary and decimal, we are really get familiar with these 2 bases, these 2 system numbers. And you're able to convert to any of the bases, okay, all around. Introduce to you to negation. So what is a negation? Take a look 1 minute and read point number 1 and 2. So what did you understand for point number 1 and number 2? What is a negation? You're converting the positive number to negative number. And if you've been given negative number, you convert to positive number. Is it correct? What she answered me here? If yes, give me the sign. Aha. Is it correct? Here, please. That's the thing. The most important, you know, in the lecture, focus what I said. That's it. And the rest, you learned yourself. Lecturer is able to facilitate you, not teaching you. You know, if I teaching you, for example, you didn't understand at all, when you come back, okay, to the, maybe your house or your hostel, whatever, all right, when you come back, you don't understand. You learn yourself. You get the information, it's not from me, from yourself. So this is the techniques of learning. Okay, you are the one responsible to yourself. You want to score this course or not, it's up to you. Okay, I only facilitate you. All right? If not, why you need to pay my salary every month? Get it? So what your friend said just now is correct. Negation is a process you convert. But I don't like using convert as a term in this case. Okay? I used to have my own term. invert. You invert. It means you're taking any of a number positive, you change to the opposite value. If you have a 1, 1, 1, 1, 1, you change to the opposite value. You invert to 0, 0, 0, 0. If you've been given 0, 0, 0, 0, you invert to the opposite number of that 0. So in binary, we have only 1 and 0. So if you get the 0 number, you convert to 1. If you get the 1 number, you convert or you invert to the 0 value. Okay? That is number 1. And number 2, once you got that, okay, in the 2 complement, what you need to do, you negate. Negate. What is the process of negate? Look at to the example. I wrote down there. So we have a positive 9. It means unsigned value for 9. This is an unsigned value. So how are we going to change this unsigned to signed, negative 9? Okay, take a look from this side. All right, how are I going to change positive to negative 9? So first of all, in the negation process, only 2 rules. First gist for today. First gist for today. The point for this lecture, the first one you learn for today. You're going to invert that positive to negative. The process how? Opposite. If you be given by this number, okay, 0, 0, 0, 0, 1, 0, 0, 1. Invert, convert to opposite number. So 1 to change to become 0, 0 change to become 1. So that is the invert. That's the first rule. Second rule, what you need to do, you're going to plus or additions with 1. 1 is a first complement, 1. This is the second rule, must. You don't know how to do this, you can't do operation for our topic today. We have a question and midterm test, and next week we're going to do exercise, week 3 exercise, this topic, a lot of operation. I want to make sure everybody know how to do the operation, computational. So you plus with 1, you negate. Negation is a process when any of a number after you invert, you plus with 1, 1 complement. So if you plus with 1, 0, plus with 1, 1. So that's the rest. So this is the number of positive 9, we convert to negative 9. Is it same? 2 complement in bracket negate. Is it same? It's the same. Okay, this is the first gist. I know those who are having class with me yesterday, you know about this one. Okay, next. It doesn't work. Oh, I not connect this thing. Another example to show to you. Take a look, 1 minute. This is a positive 18. So as I said to you in the first place, what you need to do, invert the binary number. Whatever the number you've been given, as long as it's a binary, you invert opposite value. After you invert, plus with 1. Easy, right? Is it easy? Okay. Something easy is always forgetful. Always my student, even myself, so forgetful. Something easy because it's easy. It's too easy. So this is another example. Give it to you. Plus 18. It means unsigned 18. Down there is a signed 18. So what we do, we're going to have a first rule. Invert the binary number to the opposite number. So we invert, we change 0 to 1, 1 to 0, and so on. We're done. And then second rules, what we do, we add the first complement 1. So we got that value. Okay, the process of a plus and a minus and multiplication in binary, we will go next, yeah? Another example, plus 13 and negative 9. Take a look when you want to do review for this. Okay, I skip this. All right. Second gist. All right, let's go. So the first gist, you know how to do the inversion, negation process. No second gist for today's topic. We have 5 gists. You got that 5 gists? Khalas. That's good. Okay, let me see. Addition is a process of addition. It's a process of when you have any of a binary number, you need to top up. You need to add. Okay, you see there's a plus. I have A, example B, example C. So this is very significant for you, this box. Okay, this table, consider this table. This is very significant for you. Let's go. So, when we have operation of addition, okay, the most important, only one thing in here. Look at to the overflow rules. Only that. Please don't think others. Don't think too much. Okay, just think about this one, overflow rules, in the box on your right side at the bottom. Okay, you read 1 minute. Okay, did you get the things, the knowledge in the overflow rules? Okay, overflow is happen whenever that you do the operation. Doesn't matter in addition, operation, multiplication, subtraction, and division. Always happen. It's overflow. But what is the overflow? I think when you read this, you got what does it means? Okay. In the addition, overflow is most important. Second gist for today's topic. Let's go. Example A, -7, okay, is a sign plus with +5, which is unsigned. We have a numbering which is mixed number. Okay, operation of a mixed number, negative with a positive. Look at to B, -4, okay, and plus with +4, also mixed number. But all is an integer so far in here. And then this C, D, E, and F. Look at number 1 first, addition. But before we go for this, okay, look at to the placing, positioning placing. A, 1, 0, 0, 1. Okay, they have 4 digits, plus 0, 1, 0, 1. Also 4 digits. If you take a look on B, C, D, E, F, all is 4 digits. Sometimes we giving you a questions, 4 digits plus with 3 digits. Might be 5 digits plus with 6 digits. It can be variety. So for this one, to just have what you call the glimpse of that addition operation. So I'm giving you all same positioning. Okay? Index. Look at the first operation, A, in this case. All right. -7. Okay? This one, I want to just let you know, when you do the addition, definitely they will have an overflow because you add up, you top up. It will have an overflow. Where the case of overflow? In the box, I said both positive or both negative number. So if you look at to the first number in A, 1001 is negative. Second number for A, 0101 is positive. This is +5. So this is not a same number, not both number. So if it has the overflow on the leftmost, okay, significant bits, so that one not overflow. Next, B. Look at B, positioning 1100 for -4. 0100 is 4. So we understand in binary 100 is 4, but it's a negative. There is a is a sign of a character 1 there. Okay, so this first number 1100 negative. Second number 0100 is positive. Also, is not both. It's the same type of a number. So if happen have a even 1 in the front, okay, as I showing in here 1, okay, it's not overflow. Overflow only happen when 2 numbers, when you have the operation is positive or negative. Look at the next C, also is not overflow. This one there's no overflow because we see is it even is the same positive type of a number, but there's no overflow, 0 in the front, should be fine. And then D is negative, is the same. So overflow rules is both negative, okay? First number is -4, second number -1, should be fine. But overflow in here doesn't happen. Why? Look at that. The last offer, the one that I circles in the box, has the result must be opposite sign. So we learn in here, overflow only happen when both number is the same types. It must be positive, positive, negative, and negative. If they are not same, come from the same type, you're not allowed to have overflow. That's not overflow. Even we have increment of the positioning, it's not overflow. Second rules for this case overflow, the result must be opposite value. For example, look at E. Example E. That is a positive 5, positive 4. Okay. Okay, it's fulfill our requirement overflow. Next, see the result on your most significant left bits, 1, overflow. Because 1 is a opposite type. Operations of these two numbers, 5 and 4 is same group, positive, but the result will be 1, which is negative. So this is overflow. Look at F, also overflow. Negative 7, negative 6 come from the same types. It's a negative number. And when the result comes, when you calculate, you see these significant bits, make sure that you check the positioning. Positioning only 4 bits, so we are not count most of the left, LSB. We count 0 here. So 0 is positive, opposite value. So that is what we learn. Overflow only happen when operation, both number is the same category, same type. And the result will be opposite types of that particular numbers. Okay? Okay. All right. However, let's we go subtraction. Okay. This one, number F, which number? E. Okay. Yeah, what is the E? Does that mean that the final answer that we should consider is 001? 1001, because of this is a 4 digits. But if it's a 1 an overflow bit, and no. This is negative, so overflow, opposite digits. Okay. Okay, next. We go to the addition and the subtraction. Why I have addition subtraction together? Do you remember my tutorial previous week? I mentioned that there are students ask me, okay, different section, why we need to learn first complement. This is a question. This is the reasons why we need to learn about first complement, because first complement will helping us to do any operation of subtraction in binary. That is my answer. Okay, let's we go. Take a look on this subtraction operation. Doctor, sorry, I see all plus addition. That's the symbol. No subtraction. Yeah, take a look on this case. I want you to check the box subtraction rules on your right side and the last at the bottom. M minus S. That's the formula. 1 minute. All right, done. In the box says subtraction rules. This is the third gist for today's topic. The third gist for the today topic, subtraction rules. To subtract one number, subtract hence, okay? Subtract hence is the second number of your operation. Like question number A, 1001 negative 7 is actually your subtract hence. Second number, 0010 is your first number. From another minion, okay, not minion, minion, first number, your first number here is a 2. Question B, your subtract hence is a negative 2. The 5 positive here is your median. Number C, negative 2, 1, 1, 1, 0 is your subtrahend hands. So all the second number is subtrahend hands. And then look at the bottom. I'm circling M minus S. Minus S is a subtraction operation in binary. So minus S, it means subtractions in your operation in the binary. I repeat, okay? Why I said minus S? Because of there you are. All the subtraction must be negate. If you have a positive number, you need to negate to be negative S. Negative subtrahend hands, negative number. You need to negate. Look at the example on your left. Okay, my red font, my handwriting there. All right. That. From here, there. All right, look at this. So I do to have the, this is a decimal number on the most left, 0, 1, 2, 3, 4, 5, 6, 7. I convert to binary, so I have a 0 is equivalence with 0, 1 equivalence with 1 in binary, 2 equivalence with 1, 0, 3 equivalence with 1, 1, 4 equivalence with 1, 0, 0, and so on. Okay, it's just for your reference. So I'm using this formula M minus S. So this is basically M negative S, or it's a minus subtrahend hands. So I copy here, yeah, M minus S. So in this case, M is 2. Okay, M is 2. So when I convert, I taking 1, 0. So I have a 4-bit. I just add up 0, 0 in the front. So my median 2 is 0, 0, 1, 0. So look at that. This is a positive number. And next, we have a subtrahend hands. So my subtrahend hands in here, if a 7, look at to the 7 at the bottom. 7 is a 1, 1, 1. Triple 1 there. But this is positive number. Therefore, what I need to do, when we want to negate positive number, we learned just now, negation process, we need to invert. So, we're going to invert this negative 7 to become, sorry, this positive 7 become negate, negative 7. So, what you have, which is, you have a 1, 1, 1, 1, okay? For 4-bit, look at to the near to the number 4 here. We have a 0, 1, 1, 1. So it means positive 7. I negate to become opposite. The result will be 1, 0, 0, 0. Correct? So I already invert and convert. Now plus with 1, first complement. So when I plus with 1, okay, after I've invert, second rules, first this, 1, okay, in here. So I got the result 1, 0, 0, 1, negative 7. Now, this is my answer for my negative S, or minus subtrahend hands, negative 7. Therefore, what I will do, the positive 2 just now, median, okay, I'm going to minus with 7, right? So this minus is converted to become positive now, plus. So I just plus in this case. So I take the 2, 0, 0, 1, 0. I plus with negative 7 that I negate and inverse just now. 1, 0, 0, 1. So I got 1, 0, 1, 1. So that is for this. Next, look at to the B questions. Example. In this case, median is a 5. Second, the first number. Second number is negative 2. So look at to my operation on your right side here. So I just copy the formula M minus S at the top. And after that, M is a 5. So 5 is positive number. I just take positive number in binary. When I convert, is a 1, 0, 1. So I got 1, 0, 1. Add 1 bit in the front, which is a positive number, is will be 0. Okay. So subtrahend hands in here is a 2. Negative 2. So I know in binary 2 will be 1, 0. So what happened that I just add up another 2 bits in the front, 0, 0, 1, 0. Now I need to do operation subtrahend hands to negate it. So I do invert 0 to 1 and 1 to 0, 0 to 1 and 0 to 1. So I got 1, 1, 0, 1. I'm done invert and change this positive 2, but not yet to become negative 2. So the next rule will be add with 1 complement. So I got 1, 1, 1, 0. So this is basically your negative 2. And now this is my negative s, subtrahend hence. Then I just use the operation 5, negative 2. 0, 1, 0, 1. I take it that on your right side the most. Okay. 0, 1, 0, 1. I plus with subtrahend hence 1, 1, 0. 1, 1, 1, 0. So this is the result for this operation. Okay. 5 minus 2. So take a look on C. Is it actually a same thing also? Okay. So you can take a look at this one and look at to F example. Okay. It has overflow because of it's come from the same type of these two numbers come from the same types. Classification is a negative negative, but the result produce positive 0. So that's the overflow. This is also same. It's in come from the same both number E, number E. I'm talking about number E. 7th is a positive. Second number also positive, but the result produced negative. It's overflow. Any question after the class? Okay, come back to me because I'm running out of time. This one you take a review to look at on this. This one also. This page is referring to the process of instructions of this operation for addition and also subtraction. How actually the components in your arithmetic logic units, your component of a memory, buffer, register, doing it to do this execution. Okay, next we go to the multiplication. Take a look 1 minute. This slide. For me, in a binary, if we have operations of multiplication, the thing is it's the same as well as how we do a multiplication operations in any of our system number system, like decimal. You know, like you have 40 and then multiply with 40, or 100 multiply with 30, for example, is the same. So we understand that in multiplication, it's just a matter of you shift the digit to the left. Shift the digit to the left when you be given by kind of this type of a number. So in a binary for multiplication operation, let we see the first number is a multiplicand, okay, minion, and then the second number is a multiplier, your subtract hence. So if you look at to this one, no, I cannot say it's subtract because we're not using subtraction in case. Okay, first number 1011, second number is 1101. And take a look, all right? Any of a number with a 0, okay, yeah, when you multiply with this number, definitely the result will be 0. So, but I still putting here 0, 0, okay, 0, 0, 0, 0. The first one, whenever that, this is a simple tips for you. Third gist, the third gist, okay? The third gist, which is eventually in a multiplication, you see there's a 1, okay? You just simply copy straightforward to take that numbering. The first one in here is a 1011, okay, the first number. So you just copy 1011. So we learned in a basic maths, computational, 1 times by 1, the first digit, and then next 1, okay, this one in the first digit, times by 1, okay, in the first, second digit, and then and so on. After that, 0 times by 1, 0 times by 1, 0 times by 0, 0 times by 1. So this is what we do. 1 times by 1, 1 times by 2, 1 times by 0, and 1 times by 1. So this is what we do. Okay, so it's the same in this case, but to just not waste your time when you have the multiplication operation in the binary, what you will do, okay, you just copy that number 1011. And after that, the 0, just leave it at 0, no need to calculate. And then we have a 111 here. This is for the positioning second number 1, 2, 3. Okay, 0, 1, 2. So this is a 2. This is for the last bits. So when you got all, you see all the shifted to the left, shifted to the left, shifted to the left. Basically, is following the second number operation. So the second number operation in here is based on the positioning. Okay, if you're positioning in the third, so you need to shift the last following numbers is the most on the left. Third, third placing bits or characters or digits. Okay, you need to shift it to the left. So you see the last number, 3 arrow. I write down there 3 arrows. So that's actually 3. The last one, this one. So when we want to compute as a result, just plus. Okay, take a look to the red font on your left. This is the most important. Sometimes the students are confused about this. The rest, which is smart, is fine for those average Joe. Okay, listen. This is the third gist. Okay, if been given by 1 plus 1, so I will get 0, 1. That is the result, right? 0, 1. 0, 1 in binary basically is a number 2. All right? Correct? Correct. Okay, 1, 0 is 2 in binary. So if you've been given 1 plus 1 plus 1, what will be the result? This is the result. So you have a 1 plus 1, 1 plus 1. This is total up is a 3. 3. So 3 in binary is 1, 1. So that's why this is, I got this answer. And we have, if let's say been given 0 plus 1, of course 1. 1 plus 0 is 1. Some of students always make a mistake, this thing. The second operation is 1. 1 plus 1 plus 1. Might possible you will say, why, doctors, you said that it's become 3 here. Okay. If plus should be fine. If minus, what to do? Minus, we need to borrow the carrier. So normally, my students do a mistake when they want to do this operation. 1 plus 1 plus 1. They are confusing. Some more, 1 minus 1 minus 1. Or 1 minus 1 minus 0. They're having this issue. Alright, so I write down in here. Why we have like 1 plus 1 become 1, 0? Because 1 plus 1 in decimal, 2. So 2 in binary is 1, 0. 1 plus 1 plus 1 is 3. 3 in binary is a 1, 1. So for you, those who are not clear about this one, you remember, okay, what I said today. It's very important when you have division multiplication. See, 1, we're going to move as a result 1. Here, 1, we move to a result 1. And 0, 0 plus 0 plus 1 is a 1. Look at the next bit of character. Look at the next bit of character. We have here 1 plus 0 plus 1 plus 1. So I have a 3 here, 1. 1, 2, 3. 1 plus 0 plus 1 plus 1. So it's 3. When the 3 in binary is 1, 1. So you take it, the first one, putting in here as a result. Another 1, go to the carrier. The next most left, carrier 1. So now I have in the carrier 1, 1 plus 0, 0 plus 1 plus 0 plus 1. So I got actually this case, 1 plus 1, 0, 1. So that's why I have a 0, 1, then push another 1 to the most left carrier. So you get this result. Come back to that side. I'm going to repeat, yeah? Come back to this side. And take a look of the operation again. All right, we have a 1 here. And I just push in the result down here. 1 here, 1 plus 0 will be 1. Here, 0 plus 0 plus 1 is a 1. 1 plus 0 plus 1 plus 1. Is it? So we have a triple 1 here. 1, 1, 1. So 1, 1, 1 is a 3 in decimal. So we got 1, 1. So the first one here, okay, put here. And then the next will be in the carrier. Next most left. So the most left is this row. These columns. So we have a 0 plus 1, carrier, 0 plus 1. So it's actually 1 plus 1 here. It's a 1 plus 1 here is a 0, 1. So that's why the first 0 is put here and the 1 carrier put here. So that's why they got this result. Clear? Clear behind? You? Wearing the cap? You? Okay. You're not clear, please come back to me after the lecture. I want to make sure that you know how to do this. So we also have another method, very short. It seems like a shortcut, very short one. Because as I said just now, you see the positioning. The most fastest way, you see the positioning, just you have what I call exponent index, okay, for this numbering positioning. Look at to this example, okay? All right. So I look at to this example. Basically, this is the same. The box on the most left is the same. All right, 1011 multiplied with 1101, same. See positioning the second number as I mentioned just now. Positioning is second number. This one becomes 0. This 0 become 1. This one positioning is 2. This last one is positioning 3. So if you look at that, on your most right in this box, we have a 2 power by 0, 2 power by 1, 2 power by 2, 2 power by 3. Positioning. This positioning is referring to the second number. If your second number is a 3 digits, so 3 positioning. And look at to this one again, I repeat in here. So we have a positioning 0 here for this one, 0, this one for 1, this is 1, and this is 2. So that's why you got this. So whatever number is 1 times by 1, you just copy the number. 1011 copy, 1001 copy. So you got this result. On your right side, later, tutorial, we talk about this. On your right side, it's accumulate. This is the instructions of a code when we do multiplication. Okay, this part. Take a look, 1 minute. We have an option, we have the 2 operations. On your most left is unsigned. The right side is for 2 complement integers. Let me see. All right. How we multiply? Same exactly the process, which is we have here 1001 for 9. 9 multiplied by 3 in the decimal number. This one negative. So negative, you see the difference with the positive. Positive have a 0, 0, 0, 0. Okay, the most 4 bits on the left, sign bits. You see, 0, 0, 0 is positive for 9. Negative 7, see, this one is a 1, 1, 1, 1, 1. So that's the difference. And then next, you see the value 1001, number 9. Okay, you copy this one. See the positioning. Positioning. 1 in the second number, 0011, number 3. The first one, most right, okay, significant bits is a 0. This is 1, 0, 0 in the front here, no need to calculate. Once you have this 1, 1, is good enough, just straightforward. Okay, copy the result and then you calculate. And look at to this one, okay, is a 4 digit, negative 7. I'm talking about number B. Okay, 4 digits, okay. So the most left, 4 bits another, most left on the left. Okay, most left bits, significant bits. Okay, 1, 1, 1, 1. So when you want to plus, okay, in here, 1 plus 0, 0 plus 1, 0, 0, 0. 1, 0 will be 1. Okay, 1 plus 1. 1 plus 1 is 0, 1, right? So this is 0. And carrier, push 1 to the next carrier most left. So this is the way. Do your revision about this thing. So multiplication will be the third gist. Fourth gist, division. Okay, division. The fourth gist, division. Take a look 1 minute about the division. For binary number, when you do a division operation, same like a maths formula. Okay, we have divisors. Okay, we have dividends. So look at to this operation binary in division. So we have been given 100, 10011. This is the number. We divide by, we divide 2, 1011. This is the number. So what happened that, look at to the operation, same. When you divide, you have balance when you need to subtract. Okay. So 1011. 1011. I want to compare with 1001. Which one is the biggest number? Okay, let's take a look on this. I cannot walk. I just go here. U. Which one is the bigger number? 1011 or 1001? Thank you. Give a pause. That's this guy. Correct. Which one is a bigger number? I taking first number 1011. The second number 1001. Which one is a bigger number? Of course, 1011. So, if I want to divide 1001, small number, to the bigger number 1011, impossible. It's going to giving me exponentially negative. So I can't do that. Okay? So take a look, compare this number. I touch this student, yeah? So can we compare? Which one is a bigger? 1011 and 10010. Which one is a bigger? The first number is 1011. The second number 10010. Thank you. Round pause. Why she said this is the bigger number? 10010. See the positioning. 1, 2, 3, 4, 5. 5 digits. And then 1011 only 4 digits. So 5 digits is bigger than 4 digits. So if you look at this operation, we cannot take 4 digits number. We need to take 5. So that's why we need to divide 10010 divide by 1011. This is the operation. Okay? Check first the rule for this number 4, division. Check first the number. Which one is the bigger? Inside the box or outside? So we take a look. This side. Again, this side. This number. Alright. You see, this is 5 digits, 1001. We can't to divide with this number because this is bigger. So you need to shift more and taking 0 here. So you got 10010 divide by 1011 because this is 5 digits. So that's why this one above, below here. Okay? So when you subtract, okay, subtract. See my notes there. 1 minus 0. 1 minus 1 is 0. 0 minus 1, what happened? When 0 minus 1, we need to borrow from the carrier most left. So in this case, okay, example, we have a 1, 0 here. So I need to minus with 1, okay? 0 minus 1, we can't do operation. What happened? We need to borrow from most of the left. So it's at 1 here. So when I borrow this 0 become number 2, 1, 0. 1, 0 is 2. Okay? So 2 minus with 1 to be 1. So what happened to the most left here? Become 0. Take a look again. Another example, my notes, this side. Okay? This side, look at this one. What happened that I have a 1, 0, 0 minus with 1. So this 0 minus with 1 impossible, so I need to borrow from here. When I want to borrow from this, also 0, so I need to borrow from here. When you borrow, this 0 become 2, because 1, 0. 1, 0 is 2. This one got 2. Now I want to do operation this one. So 0, I need to borrow from the most left significant bit. So when I borrow to become 1, 0 here. So I got 1, 0 here, is a 2, 2 minus with 1 become 1. So what happened to this one, 0? Just now is 1, 0, but I already borrowed from this number 0. So this 0 become 1, right? So we have another 1, 0 here, 2. You borrow, become a 1. So 1 left, they have a 1 here. Okay? There's a left 1 here. Because you borrow 2. So the first 0 borrow from the second 0. So that 2 balance become 1. That's why you got 1 there. So this is the thing, a little bit, sometimes students do a mistake about this one. So like this, okay, 0. So you borrow from here to become 1, 0. So 2 divided by, minus with 1, you got 1. This becomes 0. This one, when you happen, like this case, look at to this operation, okay? You following this operation, you divide. What happened that this one 0. So you need to borrow from here. 0 minus with 1, you need to borrow from here. So when you borrow, this become 1, 0. 2 minus with 1, you got 1. So here what happened to become 0. So when it's become to 0, all right, you need to borrow carrier. So this is the way how we do. When you borrow, it doesn't mean that the value when you borrow become 1, 0, that 1, 0, you minus with 1 becomes 0. No. The value will become 1. Because when you borrow, the value is 2. So if we have a 1 number borrow from him, it means this guy giving only 1. So this guy still have a balance 1. So once, okay, you got 1, you minus with 0 become 1. But if a 1 minus with 1, 0. But in my case example in here, what I give it to you here, okay, I have a 1, 0, 0 minus with 1. So I have a 2, 0 here. Well, this first 0, borrow the second 0. This second 0 still have a value 1. Okay, remember this case. So that's the 4 G's division. Last G is number 5. Last G is for today's topic, floating point. So when we given the floating point, we can't to run with this formula. Okay, we can't to run with this formula. Where is the formula? Take a look on this case. All right, we have this. This is a formula. In the box is the same. Okay, but don't worry. I promise you, I'm not giving you questions of floating number. Okay, I'm not going to give you a fraction number or real number. So take a look on this case. You need to do revision on this. You can't to run on this. This is a formula. We need to follow the formula. So we have, if we have given by the floating point number or decimal point number or real number, fraction number, this operation plus, minus, multiply and division, you need to use this formula. Look at that. This formula in the box, arithmetics operation, there's a formula. So you just follow that formula. Because I'm not going to include this in the final exam or in your midterm test, you are lucky. So no need to remember this, okay? The concept of study is not remember to understand. So what I understand in this case actually, okay, it's just taking the exponents of value for the particular fraction number. So in this case, if a plus, you can see 0.3 times by 10 to 3. How I can get 2 minus with 3 in this case? Just see the formula, xe minus ye. So what is a x? Is this. So this xe is a 2, and for the ye, here I got 3. So I just follow that. So you just follow that. And then there are students asking about exponent overflow, exponent underflow. Okay, you read about this one, and we're going to further up in our tutorial session next week. Okay, for those having questions after this class, I want to take attendance now.